Welcome to Night Lesson. Relax and learn along the way. Intro: The moon that hid. Imagine you are looking into the night sky through an early telescope. It is the late 17th century in Paris, a time of scientific awakening. The city's light is just a gentle glow, and above you arches an ocean of stars, clear and immense. Your gaze is fixed on the majestic Saturn, the Lord of the Rings. Night after night, you follow its slow dance across the firmament. In that very era, the great astronomer Giovanni Domenico Cassini sat in his observatory, doing just that. In the year 1671, while observing the planet with his telescope, he noticed a tiny point of light that had previously gone undiscovered. A new moon. He named it Iapetus. But as he continued his observations over the following nights, something inexplicable happened. The moon, which he had clearly seen on the western side of Saturn, grew fainter and fainter as it moved in its orbit to the eastern side. Finally, it vanished completely. For weeks it was invisible, only to reappear on the western side as if nothing had happened. This mystery deeply puzzled Cassini. How could an entire moon simply disappear and return? He spent months documenting this celestial game of hide-and-seek. Finally, he formulated a hypothesis that was as simple as it was brilliant. He proposed that Iapetus must be a two-toned world. One of its hemispheres, he surmised, is bright and reflects sunlight, while the other is covered with an extremely dark material. Since the moon always shows the same face to Saturn, it would only be visible when its bright side is facing Earth. Cassini was right. His conclusion was a masterpiece of astronomical deduction. But even in his wildest dreams, he could not have imagined what the space probe named after him would reveal over 330 years later. The cameras showed not just a world of light and shadow, but something that would shatter the boundaries of our imagination, a moon that looks as if it were not formed, but built by someone. Chapter 1: 3 Centuries in the Dark. Let us begin our journey into the silence of space, far beyond the familiar orbit of our own moon. Imagine we are traveling back in time, to the late 17th century. After the astronomer Giovanni Domenico Cassini discovered Saturn's strange, distant moon, a veil of silence fell over it. Iapetus, as it was named, remained for almost 300 years just a tiny, wandering point of light in the night sky. Generations of astronomers pointed their telescopes at it, but their instruments were not powerful enough to unlock its secrets. They could calculate its orbit, estimate its size, but its true face remained hidden. They knew only one thing for sure: this moon was different. Something about its light was strange, inconstant. Sometimes it seemed brighter, other times almost invisible. One of its sides, it seemed, reflected the sparse sunlight almost completely, while its other side seemed to swallow it. A ghost at the edge of the known solar system. The name itself, which Cassini gave it, is an echo from a long-past era. Iapetus. In Greek mythology, he was a Titan, one of the elder gods who ruled before Zeus and the Olympians. He was the father of Prometheus, who brought fire to humanity, and of Atlas, who carried the vault of heaven on his shoulders. The name fits. It suggests something primordial, a relic from the birth of the solar system, whose true nature lies hidden deep in time. Centuries passed in this patient ignorance. Then, finally, in the years 1980 and 1981, 2 messengers from humanity broke the silence. The Voyager probes, on their grand tour of the outer solar system, flew past the ringed planet Saturn. For the very first time, we saw Iapetus up close. The images were still blurry, taken from a great distance, but they confirmed the incredible mystery. One hemisphere of the moon was pitch black, the other brilliantly white. No other known moon, no other planet, showed such an extreme, sharply defined contrast. Let us dwell for a moment on the numbers that these first images provided. The dark region, later named Cassini Regio, has an albedo, a measure of reflectivity, of only 0.03 to 0.05. This means it reflects only 3 to 5% of the incoming sunlight. It is as dark as fresh asphalt or a piece of coal. The bright side, on the other hand, known as Roncevaux Terra, has an albedo of 0.5 to 0.6. It reflects more than half the light, shining as brightly as freshly fallen snow in the sunlight. It was as if a cosmic hand had taken this moon and dipped it halfway into liquid, dark chocolate. Viewed from certain angles, the pattern on its surface resembles the ancient symbol of yin and yang, that depiction from Chinese philosophy in which light and darkness, day and night, merge in perfect harmony. The division is so perfect that scientists soon affectionately nicknamed Iapetus the yin-yang moon. The boundary between the two regions was stunning, though still indistinct in the Voyager images. The probes had given us a first, fleeting glimpse, but they left behind more questions than answers. How could such a dichotomy arise? What process could cover an entire lunar hemisphere with dark dust and leave the other untouched? The scientific community had to be patient once more. A long, agonizing wait of another 23 years began before another probe would set out to finally solve this mystery. Chapter 2: The Walnut in Space. 23 years after the blurry Voyager images, a new messenger finally reaches the vastness of the Saturn system. In July of the year 2004, a silent traveler reaches its destination. The Cassini-Huygens space probe, named after the very astronomer who once discovered Iapetus, swings into an orbit around the majestic Saturn. After a journey of nearly 7 years through space, it is now its turn to unlock the secrets that Giovanni Domenico Cassini could only guess at. Over 3 centuries had to pass before the discoverer's namesake would finally get close enough. Imagine the silence in the control room as the data from the first close flyby arrived. It is New Year's Eve 2004, a moment of transition here on Earth, and 1.2 billion kilometers away, a moment of revelation. From a distance of about 123,000 kilometers, Cassini's cameras focus on Iapetus. Slowly, line by line, the first high-resolution images build up on the monitors. But what they show leaves the scientists speechless in disbelief. This is no simple, crater-pocked ball of ice. This is a world that defies all expectations. An unmissable, sharp-edged ridge encircles the entire moon. And not just roughly, not just approximately. It runs exactly, with almost uncanny precision, along the equator. Like a gigantic seam joining two halves of a cosmic artifact, this wall spans the entire moon. The dimensions are almost unfathomable. The equatorial ridge extends for a length of more than 1,300 kilometers. At its highest points, it juts up to 20 kilometers into the pitch-black void of space, while its base is up to 70 kilometers wide. Let us dwell on these numbers for a moment. Mount Everest, the highest mountain on our Earth, is just 8.8 kilometers high. Even Olympus Mons on Mars, the largest known volcano in the solar system, reaches a height of 21.9 kilometers, but its massive base extends gently over 600 kilometers. The ridge of Iapetus, however, is absurdly steep in relation to the moon's modest size, an almost vertical anomaly in the otherwise gentle curvature of the horizon. Almost 3 years later, in September 2007, Cassini comes even closer. During its closest flyby, the probe approaches the surface to within just 1,640 kilometers. The images it now sends to Earth are of breathtaking clarity. They show that the ridge is not a smooth, artificial wall. It consists of countless individual mountains, jagged peaks, and deep valleys. A complex, geological formation that only deepens the mystery. And as if this sight were not strange enough, the images reveal another, monstrous structure, the Turgis crater. With a diameter of 580 kilometers, it is one of the largest impact craters in the entire solar system. Its rim is not a gentle rampart, but a steep abyss that plunges down to 15 kilometers deep. Imagine this huge, concave bowl, brutally punched into the surface of a moon that already looks like nothing nature should produce. The combination of these two features, the exact equatorial ridge and the gigantic crater, gives Iapetus an unmistakable shape. Viewed from a distance, it resembles a giant walnut floating in space. But for millions of people who saw the images in the burgeoning age of the internet, another, much more popular association immediately came to mind: the Death Star from Star Wars. The equatorial ridge of Iapetus corresponded in a striking way to the equatorial trench of the fictional superweapon, and the massive Turgis crater was unavoidably reminiscent of the concave dish from which the superlaser fired. The similarity was so striking that the images went viral, and Iapetus became a pop culture phenomenon overnight. It was not even alone. The smaller Saturn moon Mimas, with its Herschel crater, also bears the nickname Death Star Moon. But Iapetus combines both, the trench and the dish, making it seem even more bizarre, more artificial than its little brother. For the German-speaking audience, there might be another, perhaps even more fitting association, deeply rooted in science fiction culture: the spherical spaceships from the Perry Rhodan series. Those legendary, ball-shaped spacecraft with their characteristic ring bulge around the middle, which have fired the imagination of generations since the 1960s. Iapetus seemed like a forgotten relic from these stories, a stranded spherical spaceship at the edge of the Saturn system. So there it lies, an object of wonder, on the blurring boundary between scientific reality and the boldest fiction. A silent guardian, whose sight raises more questions than it answers. And as we let this sight sink in, we slowly prepare to explore the theories that attempt to explain the impossible. Chapter 3, Arthur C. Clarke New. Imagine it is the year 1968, a year of upheaval, new ideas, and bold visions. In the midst of this vibrant time, a man named Arthur C. Clarke publishes a novel that would forever change our understanding of the cosmos. 2001, A Space Odyssey. Many know the monumental film adaptation by Stanley Kubrick, in which the journey leads to the majestic Jupiter. But this was a practical decision, made because depicting Saturn's rings would have been too complex with the technology of the time. In Clarke's original vision, in the written word, the destination was different, far more mysterious: Iapetus. Why this distant, strange moon of all places? Clarke was not just a visionary. He was also well-versed in the history of astronomy. He knew the 300-year-old mystery that Giovanni Cassini had left us. The inexplicable two-tone coloration, the fact that Iapetus became almost invisible on one side of its orbit. This moon was so bizarre, so different from anything known, that it seemed the perfect place for something extraordinary. A secret just waiting to be unveiled by a fictional future. Let us dive for a moment into the pages of his novel. The astronauts of the spaceship Discovery 1 approached their destination after a long, silent journey. Slowly, Iapetus emerges from the darkness of space. On its surface, they see that giant dark spot that had puzzled Cassini centuries ago. But as they get closer, they realize with growing astonishment that this is not a natural geological feature. It is too perfect, too geometric. A gigantic, flawless oval, so black that it seems to reflect no light, as if it were a hole in the fabric of reality itself. They have reached their destination. Time 2, the second monolith, the Great Stargate, the counterpart to that mysterious black steel that had been excavated on Earth's moon years before. In his novel, Clarke describes an idea that is as captivating as it is uncanny. Iapetus is a sentry post, a silent guardian at the edge of the inner Saturn system. Its orbit is unique and seems created for this very purpose. It circles the gas giant at a vast distance of over 3.5 million kilometers, much farther out than most other moons. And its orbit is inclined by 15 degrees to the plane of the rings and the other moons. Imagine this vantage point. From up there, you have a perfect, unobstructed panoramic view of the entire Saturn system. You see the rings in their full, breathtaking glory, not as a narrow line, but as a vast, shimmering structure. Anyone approaching this system must pass by this silent observer. And now let us return from fiction and recall the images we have already seen. In 2004, the Cassini probe revealed a world that not even Clarke could have invented. The two-tone coloration he had chosen as the setting for his novel was real. But the massive equatorial ridge, the Turgis crater, the walnut shape, all of this went far beyond anything he had imagined. It is as if reality had not only caught up with Clarke's boldest fantasies, but had even surpassed them. Arthur C. Clarke himself lived to see these images. He did not pass away until 2008. One can only imagine him sitting in front of the monitors, looking at these pictures that showed a world he had created in his mind decades earlier. Perhaps with a knowing smile, the quiet satisfaction of a dreamer whose dream was confirmed by reality in an uncanny way. The boundary between what we imagine and what lies hidden in the cosmos is perhaps thinner than we suspect. And so Iapetus remains a reminder of this blurring boundary, a silent witness to mysteries waiting to be discovered, both in fantasy and in the cold reality of space. Chapter 4: Science Seeks Answers. We have now looked at Iapetus from many angles, through the eyes of Cassini, through the lenses of the Voyager probes and the Cassini spacecraft, and through the imagination of Arthur C. Clarke. But what does science say about all that we have seen? What explanations are there for this divided world with its impossible mountain range? Let's start with the two-tone coloration, the mystery that Cassini first noticed over 300 years ago. Scientists call the explanation thermal segregation, and it describes a self-reinforcing process that has unfolded over millions of years. The most widely accepted explanation today comes from researchers Spencer and Denk in 2010. It all likely begins with dark dust slowly, almost imperceptibly, accumulating on the leading hemisphere of the moon, the side that always faces forward in its orbit. Where does this dust come from? It is believed to be material from more distant Saturnian moons, perhaps from Phoebe, a small, dark moon being eroded by micrometeorites. These tiny dust particles drift inward in a slow, elegant spiral and eventually settle on Iapetus. The surface becomes darker and darker. And here begins the wonder of thermal segregation. As you know, dark material absorbs more sunlight than light material. The leading hemisphere of Iapetus, now covered with a layer of dark dust, begins to slowly warm up. Only a very little, but enough to set a crucial process in motion. The water ice that covers the moon sublimates. This means it passes directly from a solid to a gaseous state, without the intermediate step of melting. It is as if the ice rises like a fine mist into the moon's cold, thin atmosphere. But where does this water vapor go? It migrates to the colder, brighter side of Iapetus, the trailing hemisphere, which is less exposed to sunlight. There, in the icy cold, the vapor condenses and deposits again as fresh, brilliantly white ice. The bright side thus becomes even brighter, reflects even more sunlight, and thereby stays even colder. At the same time, the dark side loses more and more of its ice through sublimation, becomes even darker, and absorbs even more sunlight. It is a fascinating, vicious cycle of extremes that, over unimaginably long geological timescales, has led to this almost perfect, sharply drawn division. A cosmic work of art, created by the simple laws of physics. But while science has found an elegant explanation for the two-tone coloration, the second great mystery remains unsolved. The equatorial ridge, that massive seam we already know from the Cassini images. How could this mountain range have formed so precisely along the equator, so steep and so high? There are several theories that attempt to explain this colossal feature. One suggests that Iapetus once rotated much faster, perhaps in just a few hours instead of the current 79 days it takes to orbit its planet once. Such a rapid rotation would have created a massive bulge at the equator, similar to a ball that spins quickly and becomes wider at its sides. When the moon was then slowly braked by Saturn's tidal forces and its rotation slowed, the outer crust solidified. What remained was this fossilized bulge, this enormous ridge that still puzzles us today. Another theory suggests that convection processes were at work deep inside Iapetus. Imagine molten material circulating in the moon's mantle, being pushed upward along a global fault zone. It would be a process reminiscent of the formation of mid-ocean ridges on Earth, where continental plates move apart and new material from the Earth's interior rises. And then there is the bold idea that Iapetus once had its own ring or a debris disk. Material from this ring could have then slowly and steadily rained down onto the moon's equator, accumulating there and forming this gigantic ridge over millions of years. The problem, however, is that none of these theories can fully explain all the observations. Each has its strengths, but also its weaknesses, and so the equatorial ridge remains one of the largest and most fascinating unsolved mysteries in planetary science. It is a monument to the limits of our knowledge and a constant reminder of how much there is still to discover in the universe. Besides these two great mysteries, there are other anomalies that make Iapetus so unique. Its unusually inclined and distant orbit around Saturn, its surprisingly low density, which suggests it is mostly composed of ice, and its almost perfect spherical shape away from the ridge. All of this contributes to its mysterious character. Iapetus teaches us that even where science finds answers, new questions await. Some things can be explained elegantly, like the two-tone coloration. Others, like the ridge, still elude our understanding. And perhaps that is precisely the appeal of this distant, silent moon. Outro, the solitary guardian. And so Iapetus continues to circle on its lonely, distant path, a silent guardian at the edge of the Saturn system. Its journey is long and leisurely. It takes almost 80 days to orbit the ringed planet once. Let us linger out there with it for a moment, in the silent, vast darkness. From here, a sight unfolds that Arthur C. Clarke could only have imagined in his wildest dreams. Saturn, not as a small dot in the sky, but as a huge, majestic disk that fills the space. Its ring system, a shimmering band of ice and dust, catches the distant sunlight and glows with a splendor that cannot be seen from any other moon. A spectacle of almost overwhelming, silent beauty. Let us think back to Giovanni Cassini. In the year 1671, he looked through his simple telescope and saw something he could not explain. A moon that disappeared on one side of the planet, only to reappear on the other. 333 years later, humanity sent a machine that bore his name to take a look. And that machine found a world even stranger than he could ever have imagined. It found more questions than answers. That is perhaps the most beautiful thing about Iapetus. It is not just a moon, it is a reminder. A reminder that the solar system is full of places that far exceed our imagination. Places where the boundary between what we know and what we dream is as thin as the shadow that shrouds one lunar hemisphere in eternal night. This journey to Iapetus is just the beginning of our exploration. In the unfathomable depths of our solar system, many more moons await, each with its own riddles, its own story. But for now, we leave the two-toned moon behind. Perhaps the image of this distant guardian, this silent, divided world of light and shadow, will accompany you on your way into the peace of the night. A cosmic yin and yang, floating in the eternal darkness, reminding us that even in the farthest corners of the solar system, beauty and mystery go hand in hand.
That was today's night lesson. Thank you for listening. If you'd like to see more videos like this, please leave a like and subscribe to the channel. Good night and sleep well.